In today's notes, we're going to look at solving literal equations or rearranging formulas. So if you look at the top of the page, I'm just going to start by reading the definition of a literal equation or a formula. A literal equation is an equation with more than one variable, where the answer will have variables in it. So in days 1 and 2 of this unit, we've been solving equations, but each equation only had one variable in it. So if we look at the table below, all the way to the left it says solve for x. The equation being 2x minus 6 equals 10. X is the only variable in that equation. Moving all the way to the right, the directions are still solve for x. And I'm going to highlight x again, but x is not the only variable in that equation. Both equations are very similar in the way that they're set up. On the one on the left, the x is being multiplied by 2, then taking that product and subtracting 6, we get 10. Over on the right side, x is now being multiplied by a, and then we're subtracting b, with the result being c. So the properties in the process that we use in order to isolate x are the same, which we'll write in the middle. But as you can see, a literal equation or a formula is an equation which has more than one variable in it. So we also have the a, the b, and the c. Many times your directions won't just say solve for x, but if you look below in our examples in 1 and 2, in number in 1 and 3, it says solve for x in terms of y and z. Number 3 says solve for x in terms of a and b. So what that means is you're going to have x equals, and then in number 1, y and z are going to be in your answer. In number 3, solve for x is going to be x equals in terms of a and b. That means a and b are going to be in your answer. So let's go back up to the table under the definition of a literal equation or a formula. That's where we most often see these types of equations, is in other classes where you're given a formula, say in science class, or if you're taking a finance class and you're looking at the profit over time. So in the one all the way to the left, solve for x. So we want to isolate x. So we want to undo the subtraction first. We want to work backwards. So we're going to start by adding 6 to both sides of the equation. So we have 2x equals 16. Now we're going to divide by 2 to undo that multiplication. And x equals 16 divided by 2 is 8. Okay, so let's go to the right and then we'll take a look at the properties. So solve for x. To undo that subtraction, again, the inverse operation. The opposite of subtracting b, just like the opposite of subtracting 6, would be to add b to both sides. Now over here, on the left, 10 and 6 are both constants or numbers which can be combined. We can easily combine 10 and 6. When I go to add the c and the b, and be careful, because even in my case, the b looks like a 6. I don't really like using b's when I have an equation with only one variable, but there's no way to avoid it in an equation with more than one variable. So just be very careful. This actually looks c plus 6, not c plus b. But I can't add a c and a b. Okay, if I had c plus c, that would be 2c. But I cannot add c plus b, so I just write it as the sum. So leave it, c plus b equals a times x. To isolate the x, again comparing the one on the left, the next step to isolate x on the left was to divide by 2. We're going to do the same thing because the a is connected to the x by multiplication, so we're going to divide by a to undo that product. Now I cannot divide the c and the b by the a. You can only divide if both terms are divisible. So since I can't divide the c and the b by a, I'm going to leave it as x equals c plus b over a. And actually, if you look at the equation on the left before we identify the properties, this 8 can be written, so here's the first step that we did. Okay, there's the 10 plus 6. We were just able to combine to get the 16 and then divide it by 2. So this now looks very similar. It's just with this expression being all like terms, we can easily combine and add and then divide the numbers. Okay, so let's take a look and identify the properties that we used. So in this first step here, actually let's use a highlighter. We added 6 on the left, added b on the right. The first step we used was the addition property of equality. And then the last step that we did, right here, divided both sides on the left by 2 and then on the right by a, is your division property of equality. Okay, now let's read the 2 stars below. They're both just highlighting what I mentioned before as we solved the 2 equations. The first one says, notice in both cases you followed the same algebraic steps. However, the second example contained only variables, but they represent numbers, so the math is the same. The second one, when rearranging a formula, the steps you take to undo operations are the same ones when solving equations. Again, so just highlighting that we're using the same steps to solve the same inverse operations when we solve a formula type equation or literal equation, and when we're solving one that has only 1 variables. So let's take a look at example number 1. And I'm going to move a bit quicker, so if you need to pause at any time, feel free to pause. So number 1, solve for x in terms of y and z. So if you read it from left to right, it says x times y plus z equals 0. So remember, we always undo addition and subtraction first, so I'm going to start by subtracting z. And 0 minus z would be a negative z. You can highlight, you can box, so I should have mentioned this. To start, if we're trying to solve for x, you can box x and have it boxed all the way through just to remind you what you're trying to get by itself. Or you can highlight it with a highlighter. I used color above, whatever method works for you. So I want to isolate x. And the operation that's going on between the x and the y is multiplication. So to undo or perform the inverse operations to solve for x, I'm going to divide by y. Because y divided by y is 1. So that actually becomes 1x. So x equals negative z divided by y. I cannot, as we mentioned above, I cannot divide z by y, so I have to leave it as negative z over y. Or you can say the whole quotient is negative z over y. It doesn't matter where that negative sign is. Next one, solve for y. So we want to box the y. We know that's what we want to isolate. And reading it left to right, we have 3 times x minus 2 times y equals 10. So I want to isolate the y, so I want to start by getting this term by itself. So I need to get rid of the 3x. So right now it's positive. To get rid of it, I need to subtract. As 3x minus 3x is 0. So negative 2 times y is equal to 10 minus 3x. The y is connected to the 2 by multiplication, so I'm going to undo that product with division. So negative 2 divided by negative 2 is a positive 1, or 1y, which is just y, equals 10 minus 3x over negative 2. Now you can leave it like that, or you can divide. I can divide the 10 by the 2. I get 5, but I cannot divide 3 by 2. So my answer is still going to have a fraction in it. Okay, so I'm going to have y equals 10 divided by the negative 2 is negative 5. And then negative divided by negative would be a positive. 3 divided by 2 I can't divide. So I'm going to leave it as 3 over 2x. So either answer is correct. And then still even from here, we typically see the x term first. So you can either leave it as y equals 10 minus 3x over negative 2. You can divide, or you can write it as y equals 3 over 2x minus 5, which is the form of the equation of a line. So I'm going to leave it like that. Number 3, solve for x in terms of a and b. So we're trying to isolate the x. I'm going to go forward without boxing. Okay, let's see how we do. So we have a times x plus b times x. So both the a and the b are multiplied by the x, and then the sum of those two equals 4. So we notice now we're solving for x, which is a part of both of these two terms. So what we want to do is pull that out front, and you want to think about, how did we get there? How did we get to ax plus bx? So up here in your thinking, you might be thinking, if I did x times a plus b using the distributive property, we get x times a plus x times b. So we're going to undo that distributive property and write it like this. We're going to pull that x out of that product and sum. So x times a plus b equals 4. Okay, still can't combine the a and the b, so we have to leave it as a sum. Okay, so now that we've pulled the x out from both of those terms, or undid that distributive property, now I need to get rid of the a plus b. And if you read it, it's really x times the quantity, or the sum of a and b. So it's being multiplied by that answer when you do the addition of a and b. So I need to divide by the whole quantity, because that is really one number, or the sum of a and b. So now that sum cancels, and I have x equals 4 divided by the sum of a plus b. And just to highlight, my answer is in terms of a and b, as it has both a and b in there. Okay, and now the next examples, 4 and 5, are both formulas that we use in geometry. So formulas that you will use much more next year in geometry. So if you take a look at the first one, take a minute. We're going to solve for w in terms of p and l. And it says that p is equal to 2 times l plus w. Think for a moment what that formula might be for. What does the p stand for, the l and the w? If you said the perimeter of a rectangle, you are correct. In a rectangle, we have 2 lengths and 2 widths. So the perimeter is 2 of those lengths, as they're the same length, plus 2 of those widths, as they are the same measure. Okay, I won't go through that for every single one, but it's good to recognize where these formulas are coming from. All right, so we're going to solve for w. So let's box w, as we want to isolate or get w by itself. Okay, so perimeter is equal to 2 times the quantity, or that sum of L and W. So what we first want to undo is that product of 2 and that quantity. So I'm going to undo the product with the division property. 2 divided by 2 is 1, or 1 times the quantity would therefore just be the sum of L plus W. And then since I can't divide P by 2, as we don't know what number that is, we just leave it P over 2. Now this is easy. The opposite of adding L to W would be to subtract L. Now I wrote it vertically, okay, but when we write our answer, I'm going to write it horizontally. So I can write my fraction, P over 2 minus L is equal to W. And then number 5, solve for H. Okay, now this is the formula for the volume of a cone, or the volume for a pyramid, as it's 1/3 the area of the base times the height, and V stands for volume. But anyways, so to solve for H, if I box the H, the easiest way to get rid of the 1/3 on both sides, okay, is to multiply both sides by some number to make it 1. So 1/3 times what equals 1? Remember, multiplication is commutative, so you can rearrange it. Doesn't matter the order it's in for multiplication. So 1/3 times what equals 1? That number is 3. So I'm going to multiply this whole side times 3. And I'll do the 1/3 times 3, which is 1. Or 1 times BH is just BH, and we can think of those as canceling out. So now I have 3 times V equals capital B times H. Okay. Now, since there's no symbol in between, again, that means multiplication. So to undo multiplication, we use division. And now we have 3V over capital B is equal to H. So now I've solved for H in terms of V and B. All right, let's finish with these last two. We're going to solve for R in the formula or equation A equals 4 pi r squared. Okay, so if I want to solve for R, let's box it. No symbols in between any of those. So it's 4 times pi times r squared. So I'm going to undo by dividing by 4, okay, and then dividing by pi. However, we can do it all in one step. So let's just divide by 4 pi. Cancel, divide by 4 pi. So now I have r squared equals a over 4 pi. Now, to undo a square, the inverse operation for a square is the square root. That cancels. I'm going to take the square root, though, of the whole term. So now I have r equals the square root of a divided by 4 pi. And the last one. The volume formula for the cone, or a cone, is V equals pi r squared h over 3, where r is the radius of the base and h is the height. Solve for h in terms of v, r, and pi. So those are all going to be in our answer. So I'm going to solve for h, okay. Just make a note that when you have pi r squared h over 3, that's also the same as 1/3 pi r squared h. It's the same thing, because there is a 1 here, even though we don't write it. So the first thing we want to do in solving for h is multiply both sides by 3 to get rid of that fraction. So we have 3v equals, and it's also the last operation that's performed on the height. We want to work our way backwards. Okay, now to isolate for h, you want to box it. There's no symbols in between the pi, the r squared, and the h, so it's not addition or subtraction, but multiplication. So I'm going to undo that multiplication with division. And now I have h by itself. And there's the bell. We are done. H equals 3 times v divided by pi r squared.